Now we're going to turn to a topic that isn't typically covered in a software engineering curriculum. That's disaster recovery. So let's first talk about a disaster recovery plan. So first, what is a disaster? So a disaster is an event such as a flood, an earthquake, a hurricane, a tornado that renders an entire data center or even an availability zone unusable. And then there are two terms that are used in disaster planning. Business continuity refers to the complete set of concerns when a disaster occurs. So what do you do with the people? What do you do with the customers? What people do you need? And so on. Disaster recovery refers to the IT portion, and that's what we'll talk about. So you can view a disaster plan as risk mitigation. So risk can be quantified. So the risk of an event is the probability of the event occurring times the loss occurred if the event does occur. And you can think of insurance. If you have no insurance, that could be catastrophic if a disaster occurs. On the other hand, if you have too much insurance, that's a financial drain. Excuse me. So the goal of a disaster recovery is to restore normal operations as soon as possible within some cost constraints. And 10% of your normal operations cost is a target for many organizations. So that's the amount of money you want to spend on a disaster recovery plan and disaster recovery backup kinds of things. And the targets have to be specified. So let's identify some factors. So there are two terms that are associated with that disaster recovery, RPO and RTO. The RPO is the recovery point objective. That is, what data in terms of time uh, will you go back to when a disaster occurs? Because if a disaster occurs, then all of the data that you're currently working with will be lost. And so you make a copy of your current data. It's called a backup. And that is the recovery point objective. How frequently do you make backups? And we'll talk about the criteria in a minute. The other number that's important is the recovery time objective, RTO. How long do you want your system to be unavailable if a disaster occurs? Okay. And again, the answer, the sort of instantaneous response to both of these is zero, but that's expensive. And not all systems are the same. So what you have to do is prioritize the systems. So your organization may have hundreds or thousands of systems. They're not all equivalent. One may send out birthday greetings, just for an example. That's not a high priority, unless it's your birthday. That's not a high priority system. And so the first step is in your planning is to prioritize your systems. And typically the priorities are set in terms of tiers. So a tier one system is a mission critical system. Your business will not be able to operate without the tier one systems available. And these typically might have a 15-minute RPO or RTO. Okay, that depends on your business and your how much money you want to spend in terms of the disaster recovery planning. But let's say 15 minutes. Tier two is 2 hours. These are important systems, but they could wait a little bit before they get restored. Tier three will be 4 hours. Okay, and again, these are less important systems. And tier four will have 24 hours. And these are all the systems that aren't tier one, two, or three. So you have to list all the systems you have to do, you have in your organization, and you have to prioritize them. And this could be potentially contentious. The other thing you might be getting an idea of is that disaster planning is a time-consuming operation and labor-consuming operation. So you don't want to do it too frequently. You do it once, and then maybe once a year you review the plan. And so you have getting the initial plan is complicated and time-consuming, but the review would be less so. So just a couple discussion questions. Excuse me. Identify 2 Tier 1 systems for your organization. Identify 2 Tier 4 systems for your organization. Okay, let's move to the notion of primary and secondary data centers. So a data center is a collection of computers, backup power source, physical security and access controls, fire suppression, air conditioning. We talked about this when we talked about the cloud structure. And so if the data center goes down, then none of these are available in that physical location. So a secondary data center is a place you would run your software on if a disaster occurs at the primary. And so if a disaster occurs, you have to switch your operations from running on the primary data center to the secondary data center. And it should be sufficiently far from the primary data center so that whatever caused the disaster didn't happen to both simultaneously. So if you expect if the disasters in your geographic location tend to be floods, then you might want to make sure that the floodplain, that one of the data centers is off a floodplain. If it happens to be hurricanes, then the same kind of considerations. To restore a system after a disaster, you have to have the secondary data center will need all of the software that the system requires and valid data for that system. And so that again gets into the RPO in terms of backup. And your disaster recovery strategy has 3 parts. First of all, you have to identify a secondary computing facility. Usually the question comes up at this point, only 2. And I haven't seen a tertiary backup data center. So what happens if a disaster occurs, one of the actions you need to do is identify a new backup, a new secondary, because the old secondary has become the primary. But doing that before the disaster occurs, I haven't ever seen that. You want to have the data, so you have to have the right set of software. Software has to be data. And these things change at different rates. So the selection of a secondary computing facility might be reviewed once or twice a year. The software could change every time there's an update, so it could change repeatedly, maybe every day. The data for your system will change continuously. So these things change at different rates, and you have different strategy for dealing with them. So the terms that are used, there's something called a warm secondary location, and that is space that you've reserved, but you haven't loaded it with any software or data. So you might have a secondary data center someplace else that you share with other organizations. And, if a disaster occurs, then you would activate that, and presumably the other organizations would not. The secondary location has a hot secondary location. That's a warm secondary location. A hot secondary location is a warm secondary location with all the software loaded. And so uh, the hot location will have software, but the data won't be up to date. And then there's something called the mirrored secondary location where everything is up to date. So both the software and the data is up to date. And in this configuration, then you can really reduce the RTO and RPO to almost zero, not truly zero, but almost zero. But then the system has to be designed to do that. So you have data in the primary. It's got to be essentially instantaneously copied to the secondary. Again, essentially instantaneously is depends on your connectivity and to the secondary data center and the amount of data we're talking about. So again, discussion questions. What are the costs of having a mirrored secondary data center? Can you use different secondary data centers for the different tiers? Why would you do that? Okay, so now let's talk about how you manage data. So for tier 2 to 4, right, the non-mission critical systems, uh, there you have to worry about backup frequency and you have to worry about storage media and recovery time. So when a disaster occurs, you have to assume that the data in the primary data center will be lost. And so you have to have access to the data center. That means you have to take a backup. And the frequency of the backup is determined by the RPO. And tier 4 systems should be backed up once a day. Tier 3 systems backed up every 4 hours. And tier 2 systems backed up every 2 hours. So that reflects the RPO of those particular tiers. And again, you organize your system into tiers so that you don't have to do this for every system. You just have to think about it for the different tiers. And you have two different options for storage. One is you can copy the data to disk. So you can have online storage to disk. You have disk at the secondary data center. And the backup consists of copying the data from the primary to the secondary over a network. The other is you have offline storage to tape. And why would you do that? Well, first of all, it may be you may have a lot of data, um, and it is too time consuming to copy that data to the disk. There's an old joke, what's the fastest way to move a terabyte between New York and San Francisco? I don't know if this is still true. And the answer is put it on a tape, put it on an airplane, and fly it there. So if you have a lot of data, then moving it over the network becomes impractical, and you put it on a tape. Or it may be that tapes are cheaper, so it may be that you put it on a tape just because of cost. But then you have to think about recovery time. So let's suppose you put it on a tape, you store the tape in some sort of secure warehouse, and then a disaster occurs. You have to physically move the tape from its storage location to the secondary data center. Well, maybe after a disaster, traffic is really heavy, or bridges may have gone out. So you need to think about things like that when you think about tape storage. So again, two reasons for using tape. Uh, Tier 1, it has to be online. You can't get 15-minute RPO and RTO with tapes. Takes I don't know if you've ever dealt with tapes, but it takes 5 minutes just to load the tape onto the tape drive. Although these days it's a lot more automatic than it used to be. And so you need to keep an up-to-date copy for tier 1, you need to keep an up-to-date copy of the system data at the secondary data center. And the replication can be bidirectional, that's called master-master, where either data center can be updated and then they have to be synchronized. You need to worry about consistency. in terms of making sure that both data centers, if you have master-master, that both data centers have the same set of data. Or it can be master-follower, where you only update the master and then copies are sent to the secondary data center. You also have a set of unreplicated data. There are things that you don't need to keep update. So session data, the data that manages a user session. It becomes a business decision. If a disaster occurs, are you willing to require your users to log in again, create a new session? If the answer is yes, then you don't need to replicate session data. If the answer is no, then you do need to replicate session data. And then there are a lot of static data. There are videos, there's web pages that portions of the web page may not change, and so on. And so those you don't need to worry about quite as much. You need to have a copy at the secondary data center, but you don't need to worry about replicating it particularly. And then there's a concept of big data. So big data is data that's too big to back up. And so either on a tape or on a disk. So what you do if you have big data is you create what are called shards. You divide the big data into pieces, and then each piece is treated as a separate data set. And it's either backed up to tape or it's replicated on disk. And then in order to access something, you have to be able to figure out which shard it's in. So discussion questions. There's something called incremental backup. What is it? And when is it used? And then banks are much more now on the public cloud than they used to be. What does that do to their disaster recovery strategy? It used to be that banks had their own data centers. Is that still the case? And what would happen if they used the cloud as a secondary or even as a primary? Okay, so that's data. Let's talk about software. The software at the secondary location has to be the same as the software in the primary location, down to things like patch numbers. And you can do this with a configuration management system. If you'll recall, a configuration management system makes copies and propagates those copies. So it could propagate copies to the secondary data center just as well as to your laptop. It would be different software, but it's the same mechanism. And it could be the software at the secondary data center would be updated as a portion of the updating process. So when you update software, you deploy it into production. Well, you also, at that point, could deploy it to the secondary data center. That would be in your script. And so a copy of it would be at the secondary data center as well as at the primary data center. You have to worry about things like licenses and keys. So some software has to be licensed. Okay, well, the copy that you have, you have to look at your license and see whether it allows you to have multiple copies. If it doesn't, then you need separate licenses. If it does, you need to make sure that the license is available at the secondary data center. Same thing with the keys. So discussion questions. What are the software costs associated with keeping it mirrored or at a hot secondary site? What are the database considerations for maintaining consistency? One of the things you really worry about with databases is, in distributed databases, is keeping the data consistent. So finally, let's talk about rollover. So failover is the transfer of activity to a secondary database, secondary data center. And so first you have to decide to do it. So you have to trigger something that says we're going to go to the secondary location. Then you have to activate the secondary location and make sure that the data is up to date. So again, depends on how you stored things. And then finally, you resume locations at the secondary data center, and that gets into RTO. So if your RTO is 15 minutes, then you don't want this process to take more than 15 minutes. If your RTO is less, again, less. If it's more, then you have more time to do the failover. You can do this manually or you can do this automatically. So there's cost associated with moving the data center. You may lose data. You may be unavailable for a period of time, maybe short, but still, you don't want that to happen. So you can either fail over based on a set of rules, or you can fail over based on someone making a decision, a manual failover. The problem with having a set of rules is that you may have false positives and you may fail over even though it's really a network problem, not a data center problem, and so on. Okay, this is the automatic failover. So again, possible false positives, and it may cause database inconsistency if you moved it over when there wasn't a true disaster. So then the question is, we have a process. Okay, processes should be tested. How do you test the failover process? Well, you could do it during normal operations. That gets tricky, especially if the test fails. So you do a test, a failover test while the system is active, and it turns out that it doesn't work for one reason or another. It's a test, and then all of a sudden your current users are unhappy. Or you can do it during downtime. And so this is the way banks work. They have scheduled downtime when the system is not available. And during that downtime, they will test the failover, often in the presence of regulators. So again, with banks, regulators want to make sure that the banks operate, and managing a disaster is part of that operation. So again, discussion questions. If you can't schedule downtime, how do you perform the test? And then what personnel do you need to have available during the test? And the same thing in terms of the failover. If you're actually doing a failover, what personnel do you need to have? You think about getting systems to start appropriately and so on. Okay, so that's the end of this chapter.